Alright guys, let's see if I can make this video for you. Be helpful. Understanding why this system's shit, problems it has and all that. Alright, so this is your flame heater unit here. I'm just going to give you a little insight on how it works. This here is your in port. It's a little filter for it. It's a little piece of felt filter. This is your out port. You know, there's return fuel line. Same thing, a little piece of felt filter there. This is here your fuel nozzle. This creates the spray. Obviously, this is your little seal washer. This is a filter for the spray nozzle. And this is a tiny little check ball. See that, guys? Little check ball. That's largely some of the issues here, but we're going to get into some different issues. So that's a check ball. This valve, or this nozzle, does not work quite like a standard diesel heater nozzle does on an in-house heater system, which is just an fuel just goes in, dumps out the nozzle. With this system, the fuel goes into this little screen. This little screen goes onto your nozzle, goes in, it goes into this outer cavity. See here, you've got this outer cavity, goes in there, and what doesn't come out of your spray tip will come back out this inside cavity here, which I'll try and show you. See that inside cavity? That inside cavity is also what this little tiny check ball seals against. We'll get back to what that does later because it actually serves two functions. All right, so we're going to put that down. This here is your pressure regulator control valve. Okay, so here's an interesting thing. This thing has multiple sealing surfaces, O-rings. So here, you've got a one-way check valve seal on the end of that. That has a spring against it. That controls the amount of pressure that comes out of the spray tip. Then you've got this item. Now this has another spring. There's an O-ring which can seal, or which can fail to seal and leak. And then you have this, which, as you can see on this one, is already nice and dirty. Honestly, most of this is pretty dirty. I cleaned up some of it, but anyway, this is another one-way check valve. This is the return line pressure. This doesn't control the pressure coming out of the nozzle. This controls the pressure of the return line. And now this actually has another little rubber sealing surface, which again can get dirty, hard, whatnot, and it can malfunction, causing the return pressure to just be set too low and just the tip won't even do anything. All right, so that works in conjunction with the main system. That goes together. This is your backing plate. Again, an O-ring that could fail, and your little snap clip. So now here's how this system works in the main body here. So you've got your in system. This line comes in, fuel comes in, and it doesn't come directly to this spray tip here. What it does is it comes down and it enters inside this housing. Comes in this main cavity. The fuel there comes in the main cavity. After it gets, and then you'll actually see there's another, there it is, you can just catch it with the light. There's another port right there, that little port there. So that port gets sealed up by this check ball so that the fuel can't go backwards into the return line of the nozzle. Instead, the fuel must enter this right there. Let's try and figure it out. There it is. That much larger port. See that? See that light? That's actually right here. If we can catch that. Probably should have a flashlight, whatever. So that line comes out. And then, see if I can figure out how to turn a light on here. I don't really know how to. Not really a camera person, so. Alright, well, I got a flashlight over here. Let's see if this helps. Alright, so. There you go. So see how there's two ports in your body? The internal one, the center line, see that center port, actually has an O-ring also. That's a seal that's designed to help seal the edge of this check ball seat to this housing so that can't leak. Another spot that's going to fail. You know, these things are old. They've had all kinds of cruddy fuel in them. But anyway, Now you see that lower hole? Not the center one, but that lower one? That's going to be the fuel feed for the fuel filter for the nozzle. The fuel will go in there. If all these regulator valves are working properly, the fuel will go in that hole. It will go through this filter screen. It will go into the injector body. The majority of the fuel needed will come out of the injector nozzle and make a nice spray pattern, which gets ignited by that spark plug. We'll get into that system in another video. And what doesn't come out of that nozzle will come out of this center tube. It'll open up this check ball, preferably not leak through that O-ring that you'll see inside there. Again, we'll show that O-ring. See, yeah, I'm not really good with cameras, so see that? On the center line, there's actually a rubber seat. Mine's actually damaged, not surprising. So hopefully that doesn't leak. The fuel will go past the check ball. It will then push against this little white seat. It'll unseat the valve based off of the spring pressure required by this spring and the back pressure of our secondary one-way valve. It'll come off that seat. It'll come out, and once the fuel unseats all these, the fuel will then come out of your exit line. Now, some fuel will stay in this housing, of course, and it'll help bleed that system out and everything. Not going to lie, I don't 100% understand why this system was designed so complicated. I'm not going to act like I'm an expert. Don't really, based off of what I see here, understand why it needed to have this secondary one-way relief valve. I'm not gonna lie, I haven't put a lot of time into it. It's such a trash system. Just seeing one apart and understanding the way it's designed, how many things can leak, how many things can fail. But this is definitely what sets the pressure regulation. Once that off seats for the nozzle pressure, and I'm assuming this is set for. This is probably controlling the return pressure, because again, this is just another spring-loaded seat that then has to be released. So once the fuel comes out, past here, you've got this O-ring, which is going to prevent it from going anywhere, and then it's got another open cavity, which is then going to have to press on this other valve seat. Once it gets through all that, then the fuel can go back out this port. So anyway, I don't know. Hopefully this video is useful to some of you guys. I'll post it on YouTube. Just to give you an idea, because I know some people I've talked to are like, they think it works almost exactly like a heater works in their oil furnace, where fuel goes in, fuel sprays out nozzle, fuel gets ignited by the spark plug. You know, you would think that's how they designed it. This is an overly complicated trash system. These check balls, these things can get corroded, like this one is, all gummed up, and either get stuck or not release off the seat. These check valves can obviously get gummed up and dirty. I mean, you can see this one's already, look at that. It's like, just wiped out my thumb, and it's, and that's not even, most of it's not even coming off. It's so, yeah, ew. So you got that. You got these O-rings. You've got what? 1, 2, 3 internal sealing surfaces, 1 external sealing surface, a check ball that can fail. Obviously, the fuel lines can fail, but what I've seen mostly is this external O-ring fails. These check balls can fail, and allow fuel to leak in past the nozzle and just dribble out of there. So, and then of course, like I said, what feeds all this is an external fuel pump, and then you've got the circuit from the fuel pump. Then you've got the external filter that feeds to this. Then you've got a little igniter box. You just got a lot of systems here they've got to work perfectly. And again, if you were to take this entire system, rebuild it perfect, all new O-rings, scrub and clean everything, I don't even know where you would get parts for things like this one-way valve seat. You might be able to reuse the old one. This is just a nylon seat. That's probably can be serviced. This is an O-ring. I'm sure you could just service that. And this O-ring with some generic parts. The nozzle, I mean, this is just like a heater, could be serviceable. It comes apart. It's set up to be removed, cleaned. The pinhole can be cleaned. I personally wouldn't waste my time because, like I said, it's a trash system. And if I did live in an area where it was that cold, that I got such severe cold weather that, I needed some type of intake heater, and for some reason I couldn't use a block heater, like my personal driver has a block heater, I would just buy they're still used in the commercial world, an ether start system, or just spray a little ether in your air filter and crank it. It's always best when you're going to use ether on a unit to have the engine cranking while the ether is being sprayed. That's one thing people don't understand. The largest reason that people wind up damaging their motor is, one, too much ether, but two is spraying loads of ether and then cranking the motor, and the motor essentially pre-ignites almost like the hydrolock effect and damages the motor. Seen that, but again, that's why you should always have the motor cranking, preferably while you're spraying the ether into it. That's why an ether kit is best. That, and it's obviously more convenient. I don't live in an area like that. I got a block heater. God forbid I want to do it, I'll just use the block heater. But if I did live somewhere that cold, I would install a ether kit. So, all right, I hope this video, guys, was helpful to you. Just give you an idea why these things are so common for leaking, why they're so common for malfunctioning, why it's not even worth fixing them up. Because even if you have this unit working functional, perfectly functioning, then you got to hope you got a good spark plug, a good igniter box, and you got to hope that you've got clean enough fuel that it's going to ignite when atomized. Because remember, this is to atomize diesel fuel to a level that can be ignited at low temperatures with electrical ignition, which, unlike gasoline, is very difficult. It needs to be under extreme pressure. More importantly, it needs to be extremely atomized. It's not like, if you put diesel fuel in a spray bottle and you just sprayed it out, even a lit match, you would see it just kind of go, wouldn't do anything. So, all right, guys, I'm going to end this video. I think that's good enough. Catch you guys later.